Okay, this is question set 2. First question. A, we're asked to find partial fractions for this expression, and B, we're asked to use the result to find this integral. So partial fractions, the first thing we need to notice is this is a difference of two squares. So we're going to rewrite it as x over x plus 1 times x minus 1. And that's going to be a over x plus 1 and b over x minus 1. That means that a times x minus 1 plus b times x plus 1 must be equal to x. If we let x equal to 1, we get rid of the a's, and we have 2b equals 1. Which means that b is a half. Then we're going to let x equal minus 1, so that we can eliminate the b's, and that will give us minus 2a is equal to minus 1, and therefore a is also equal to half. So when we rewrite the expression, it's going to be 1 over 2 x plus 1 plus 1 over 2 x minus 1. Okay, and that's part A complete. Now, in part B, we're asked to use the result of A to find this integral. There are a number of ways you could create this expression, but we've been clearly led here. We've got to use what we found in A. So first thing we're going to do is we're going to rewrite the integral in terms that look like this. We can see that it's x squared times x over x squared minus 1. So I've now got the expression that I had in A, so I can substitute in the partial fractions that I found. So it's going to be x squared times 1 over 2x plus 1, plus x squared multiplied by 1 over 2x minus 1. Now these are not in a form that I can integrate at the moment, so I need to do a bit of work. I'm going to take out the factor of a half, just to clear things up slightly. And I've got x squared over x plus 1. I want to try and get rid of the x squared because I don't mind having an x under here, I can use an ln function. But I can't have a quotient. So I'm going to express, in this case, x squared as x squared minus 1 plus 1. And what that means is I can express this whole fraction as x squared minus 1 over 2x plus 1 plus 1 over 2x plus 1. Now I've taken the 2 out actually, so it's going to be x squared minus 1 over x plus 1 plus 1 over x plus 1. And I'm going to do the same with the second one. So I'm going to replace that x squared with x squared minus 1 plus 1, and I'm going to split the fraction. So x squared minus 1 over x minus 1 plus 1 over x minus 1. Now, again, this is a difference of two squares, so we'll just remind ourselves that x squared minus 1 is x plus 1, x minus 1. And so if I have that in here and in here, I'll be able to do a little bit of cancelling to get rid of one of the factors. So instead of x squared minus 1 over x plus 1, I've got x plus 1, x minus 1 over x plus 1, which means that x plus 1's cancel out and I'm left with x minus 1. I've still got this 1 over x plus 1. In this one, the x minus 1 cancels with x minus 1 and I'm left with x plus 1. And I've got 1 over x minus 1. Now, I have a lot more terms, but each of them is fairly easy to integrate. Okay, so I'm just going to do a small amount of tidying up. I've got an x here and an x here, so I've got 2x. I've got a plus 1 and a minus 1, so I can forget about them. So a half 2x plus 1 over x minus 1 plus 1 over x plus 1. Now I'm just going to integrate. So I've got a half 2x squared over 2, so x ln x minus 1 times 1 plus ln x plus 1. Using our log rules, that will give us a half of x plus these two logs added will mean that our x minus 1 multiplied by our x plus 1, which gives us x squared minus 1. So we'll have ln x squared minus 1. And what we've forgotten, it's an indefinite integral, so we must have our plus c. Okay, question 2. We're asked here to use implicit differentiation to find the derivative in terms of x and y. This is our equation, and so we're just going to differentiate everything with respect to x. First thing we need to notice is this is a product. So let's just take this out and make u equal to x and v equal to y. U dash is then equal to 1 and v dash is equal to dy by dx. And that means that this product is equal to u dash v plus v dash u. So that's y plus x dy by dx. And then we've got y squared, which differentiates to 2y times dy by dx equals, and the 2 differentiates to 0. Now I want to collect and make the subject dy by dx, so I'm going to have x plus 2y dy by dx equals negative y, and therefore, dy by dx is equal to negative y over x plus 2y. For the second part, we're asked to find the equation of the tangent to the curve at point 1, 1. This is a higher question, really. So we know the derivative, which tells us the gradient at any given point. So we're going to substitute in 1, that tells us the gradient. Then we're going to use y minus b equals mx minus a. So the gradient is equal to minus y, which in this case is minus 1, over x plus 2y. That's 1 plus 2. So that's negative a third. And we're going to use y minus b equals mx minus a, with the gradient being minus a third, a is 1, and b is 1. So y minus 1 equals negative 1/3 x minus 1. I'm going to multiply through by 3 to get rid of that fraction. So 3y minus 3 equals, I'll multiply at the bracket at this point also, negative x plus 1. Then I'm going to move things over to tidy up. So x plus 3y equals 4. Okay.